Hey guys, in this lesson we would understand the properties of similar triangles and their applications. From the previous lesson we already know what are similar triangles. Let's say if we are given a question where we have to name the similar triangles and explain why they are similar, then how do we do that? If we are given triangle ABC and triangle DEF with the known side lengths, then how do we prove if the triangles are similar? We know similar triangles are the triangles that have same corresponding angles and the side lengths are supposed to be in the same ratio. So if we are given the two triangles with the known side lengths, how do we find out if the triangles are similar or not? As we know, the similar triangles need to have side lengths in the common ratio. So we would find out what is the ratio of the corresponding side lengths. Then we compare side length AC with DF. AC length is 1.8 centimeter. DF length is 5.4 centimeter. When we find the ratio of AC to DF, it is 1.8 is to 1.4, and when we reduce it down to lowest terms, we get it 1:3 ratio. Because when we divide AC with DF, 1.8 divided by 5.4 is equal to 1/3. Therefore, the ratio of the length of the smaller triangle to the length of the bigger triangle is 1:3 for one of the side lengths. Let's see what is the ratio of the other side length. Let's compare AB with DE. We know AB is 3 and DE is 9 centimeters. When we take the ratio of AB and DE, we get 3.0 is to 9.0. That is equal to 1:3 again. So when we compare AB and DE, that is the second corresponding side length that has the same ratio as the first corresponding side length. Let's compare the third corresponding side length, that is CB and FE. CB is given to us as 2.5 centimeters and FE is given to us as 7.5 centimeters. When we divide CB, the smaller side triangle, with the side of the bigger triangle, we get 2.5 divided by 7.5, which is 1/3, or if we have to write it down as ratio, it will be 1:3 ratio again. Now we notice that the three ratios of the three corresponding sides are exactly same. If the ratios are same for the corresponding sides of the two triangles, then the two triangles are called similar triangles. Therefore, in this particular triangle ABC is similar to triangle DEF. This sign is the sign of similarity. We can put this sign of similarity between the two similar triangles once we are able to prove them similar to each other. And this ratio that is equal is also called the scale factor. So in this particular example, the scale factor that we've got by dividing the side length of the smaller triangle with the side length of the bigger triangle is 1:3, or we can write it as 1/3 is the scale factor. So this is how we prove the two triangles similar when we are given the side lengths of the triangles. Let's take up another example where we are not given the side lengths. However, we have to figure out if the two triangles are similar or not. Then how do we do so? Let's say we are supposed to prove this triangle similar, and then we have to name the two similar triangles. We notice that the two triangles in this particular shape are triangle PXA, and if we are reading the other triangle, we have to read the other triangle in the same way as we have read this triangle. So we would read this point that's common for the two triangles first. So we would write on triangle P. Then after P, we would write on T and N. So triangle PXA is similar to triangle PTN. But before writing that these two triangles are similar, let's prove them similar first. Now here we are not given the side lengths. So the other scenario in order to prove the two triangles similar is to use their angles. However, we do not even know the angles of the triangle. But we know that these two lines of the two triangles are parallel to each other. When the two lines are parallel, then certain angles are formed that are seen to be forming Z pattern or F pattern or C pattern that is expected from the students to know from the lower grades. So when these two lines are parallel, this forms a very clear Z pattern. So as this forms the Z pattern, the angles within the interior of the Z pattern are called alternate angles, and when the lines are parallel, these alternate angles are equal. Therefore, we have angle AXT equal to angle XTN. AXT is this angle and angle XTN is this angle. So we've got two angles equal, and we notice that this angle lies in this triangle and this angle lies in this triangle. So we are able to get one angle of each triangle equal to each other. Let's see if we can get the other angles equal as well. Now, since these two sides are parallel, there is another Z pattern that we can see is beginning from X towards A. So we notice this is a Z pattern as well, where the angles are XAN and ANT. So angle XAN is equal to angle ANT, as these two angles lie in two separate triangles that we are considering to prove as similar, and these angles are equal. So we have got another pair of angles equal in the two triangles. Now always remember, in two triangles, whenever we get two pair of angles equal, then automatically third pair is supposed to be equal. However, in this case, we can easily see that the other pair or the third or the last pair is also equal, as we notice that the third pair is formed at this point and at this point. Because in this triangle, this is the left out angle, and in this triangle, this is the left out angle. These two angles are supposed to be equal to each other because they are vertically opposite angles, and we know vertically opposite angles are always equal as well. So here we can write down angle APX. So we can say angle APX is equal to angle NPT, and we can write on the reason here is that these angles are vertically opposite angles. It is always recommended to write on the reasons in the brackets along with the equal angles that we are proving equal. Angle AXT was equal to angle XTN because of the Z pattern. Similarly, angle XAN was equal to angle ANT because of the Z pattern as well. So we have written down the reasons for all the three angles that we have proved equal to each other in two separate triangles. Because we know when the two triangles have equal corresponding angles, then they are said to be similar triangles. So we can write down triangle PXA is similar to triangle PTN. Reason being is AAA property. That means all angles are equal. So AAA means three angles are equal. So we can either write it down as AAA property, or we can write down all angles are equal. This is a because sign, and this is the similarity sign between the two triangles. We do not put the similarity sign in the beginning because in the beginning we have to still prove that the triangles are similar. After we have taken these three conditions up, we have already proved that the triangles are similar, so that is why we write down underneath these three conditions that the triangles are similar because of these three angles proved equal to each other. So if you're asked to write down the two similar triangles, we have got the answer here, and then why are these two triangles similar? We've got the answer here. Let's take up simple applications of similar triangles. Let's say we're given a question, the triangles in each pair are similar, find the unknown side lengths. So in this particular question, we are given the two triangles that are already similar, so we need not prove them similar. All we have to do is just find out these unknown side lengths. So we have to find out the value of F and find out the value of D. So as we know, triangle ABC is similar to triangle DEF. We need not prove that the triangles are similar. We can notice here that the corresponding angles are equal. So this angle, single mark, and this angle with a single line, that means angle B is equal to angle E. This angle is with a double line, this angle is with a double line. So here angle A and angle D are equal. This angle is marked with a dot and this angle is marked with a dot. So that means these two angles are equal. So equal angles are usually represented with similar marks. As the three angles are equal, so definitely the triangles are similar, and they have given us the triangles are similar, so we need not worry about improving them similar. Because we are asked to find out the unknown side lengths, we know similar triangles have, we can write on triangles with this symbol, triangle with apostrophe S. Same scale factor. Scale factor we have learned in the previous example is the ratio of the side lengths. So we would be using the same scale factor for finding the unknown side lengths. But how do we get the scale factor is whatever is the one corresponding side length that is given to us for the two triangles, we would be using that to find out the scale factor. To find out the scale factor, all we have to do is just take one length of one of the triangles and divide it by the corresponding side length of the other triangle. We can either take the bigger length triangle divided by the smaller length triangle, or we can do vice versa. The answer is going to be same, it's just that the ratio is going to be flipped. As we know, the two triangles are similar, therefore the side length ratio DF over AC would be equal to the side length ratio EF over BC would be equal to the side length ratio of DE over AB. Now always remember, if we are taking the bigger triangle side lengths as numerator, we have to take it for each of the sides the same way. Bigger over smaller triangle side length. Bigger triangle side length over smaller triangle side length. Bigger triangle side length over smaller triangle side length. If we are taking the opposite way, then every side length is going to be taken in the same way. Whenever the triangles are similar, we know the angles are equal and the ratios of the side lengths are going to be equal as well. So we can show that like this. And another important thing to remember is that we cannot write down DF over AB. It has to be corresponding side lengths. And how do we know that this side length is corresponding to this side length is using the angles. So this side length is between the two angles that are marked as double line and a dot. So this side length should also be between the two angles that are marked with a double line and a dot. This side length is corresponding to this side length. And how do we know that is? This side length is between the double line marked angle and a single line marked angle. This side length also lies in between the double marked angle and the single marked angle. That's why we write down DE over AB. And similarly, we get the third side length ratio as well. Now, out of these three, we know the complete ratio for this first fraction because we know DF length, that is 12, and we know AC length, that is 6. So we would be using DF over AC, as DF is given to us as 12 and AC is given to us as 6, to find out the scale factor. So scale factor we always find out using the two corresponding side lengths that are given for both the triangles. Here the scale factor that we get is 2:1, or we can just simply write down 2 is the scale factor. That means the bigger triangle side lengths are double the side lengths of the smaller triangle. So in place of DF over AC, we've got 2. So we would put 2 underneath this, equal to, we are looking for EF, that is represented with D, lowercase, over BC side length, that is given to us as 7. So we can first use DF over AC equal to EF over BC, and once we are able to get this side length, then we can use the scale factor DF over AC with DE over AB in order to get the unknown side length here. In order to solve for D, we just have to move this 7 on the other side, and we get 2 times 7 is 14. So D is equal to 14 centimeter. This is just to show the work. Otherwise, we know that the side length here is double the side length of this because the scale factor is double. So we can just write down this as 14 because 7 times 2 is 14 centimeter. Similarly, in order to write down the answer for lowercase f side length, we know this is going to be double there, so that would be equal to 8 centimeter. But how do we show the work for this one as well? Because in this case, we are looking for DE, so we just have to write down DE over AB equal to the scale factor. So always remember, we get the scale factor from one of the ratios, and we can just put that scale factor equal to the ratio of the other sides. DE is what we are looking for, and that is the side F. AB is given to us as 4, so we put F over 4 equal to 2. F would be equal to 2 times 4, which is equal to 8 centimeters. And this is how we get side F and D for this particular question. As we see here that in this particular example, we can use the properties of similar triangles to find out the unknown side lengths. Similarly, we can use the properties of similar triangles to find out the unknown area of the triangle. Let's understand that with an example. Now let's say we're given triangle GHI and triangle KLM, and we know the triangles are similar. How do we know that? Is because the corresponding angles are marked with similar signs. That means they are equal. So angle H is equal to angle L, angle G is equal to angle K, and angle I is equal to angle M. Therefore, we are given triangle GHI is similar to triangle KLM. So when the triangles are similar, that means their sides are in the same ratio, and we can use the sides to get the scale factor. We do not know the other two corresponding sides, but we know one of the corresponding sides of the two triangles, that is side GH and KL, that we can use to find out the scale factor. In this particular example, the question wants us to find out the area of the smaller triangle, that is GHI. We are given the area of the bigger triangle. Now what we will be doing here is that first we will be finding the scale factor. So because the triangles are similar, therefore we can say LK side length divided by GH side length is equal to 12 over 8. We reduce it down to lowest terms and we get 4 times 3 is 12 and 4 times 2 is 8. So this is our scale factor. Now always remember that when the two triangles are similar, they have a similar scale factor of the side lengths. Also, they have the same square of the scale factor for the area of two triangles. What does that mean? This means that if LK over GH scale factor is 3 over 2, similarly LM over HI will also have a scale factor of 3 over 2, and KM over GI will also have a scale factor of 3 over 2. So these are the corresponding sides, KM over GI and LM over HI. So all of these side lengths will have a scale factor of 3 over 2. And the areas of the triangles, because here we got the bigger triangle side length as a numerator over smaller triangle side length as a denominator. Here also bigger triangle side length over smaller triangle side length, bigger over smaller. Similarly, the area of the bigger triangle, that is KLM, and the area of the smaller triangle, that is GHI, will be related to each other using the square of the scale factor. And the scale factor that we've got is 3 over 2. So it would be 3 over 2 square. Now we are given the area triangle KLM as 54. We are looking for the area of triangle GHI. So we would write down area triangle KLM as 54. We are solving for area triangle GHI. When we know the area is in the ratio of square of the scale factor, let's keep this area as a variable. 3 square is 9, 2 square is 4. We are looking to solve for a. We would just isolate a by cross multiplying. So 54 multiplied by 4 is equal to 9 multiplied by area, or a that we are looking for. Now we would be isolating a, so we will move this on the other side, so this gets divided, equal to a. When we put this all on the calculator, we would be able to get 24 as the a value, and this a value is representing the area of triangle GHI. Therefore, the area that we get for triangle GHI is 24 centimeters square. And this is how we use the scale factor to solve for the unknown area. Let's summarize everything. If we're given the two triangles to be similar, so in this case triangle ABC is similar to triangle PQR, then their corresponding angles are equal. So angle C is equal to angle R, angle A is equal to angle P, angle B is equal to angle Q, as well as their sides are in the same ratio. That's called having the same scale factor. So we can write on side CA over side RP is equal to side CB over side RQ is equal to side AB over side PQ, and that would be equal to the scale factor. Scale factor is represented with lowercase k. Apart from having the same scale factor for the side lengths, for similar triangles, we have another property, and that is area of both the triangles are also related. So area triangle ABC divided by area triangle PQR would be equal to square of the scale factor. These are the three important properties of similar triangles when we know that the triangles are similar.